on lecture one, I like to think about three tiers of knowledge dealing with climate change: science, technology, and policy. And I particularly drew this as a triangle such that, the science is kind of the base here, then the technology, finally getting up to the policy. We did 3 lectures on science, 2 on technology, and now we're winding up on policy. But before we get into that, I want to go through a little bit of introduction and context to kind of set the stage, so a little bit of review of what we looked at in earlier lectures. And just remind everyone that there is an overwhelming international scientific consensus on the following 3 points. Over the past 120 years, the Earth has been warming and the climate has been changing at alarming rates. The global warming and resulting climate change of the past 120 years have been driven almost exclusively by the accumulation of greenhouse gases in the atmosphere caused by human activities. Without dramatic reduction in the emission of greenhouse gases into the atmosphere, the Earth will continue to warm and the climate will continue to change to the detriment of humankind. Now, that's not just me speaking. Basically, no legitimate science organization in the world would disagree with those 3 points. And indeed, here's a partial list of leading science organizations that have made formal declarations of confirming human-induced global warming, including the most prestigious organizations in the world, such as the U.S. National Academy of Sciences, the U.S. National Research Council, and the American Association for the Advancement of Science. As we talked about in Lecture 2, there is Nobel Prize-winning science behind these statements and these endorsements. And for any climate change deniers out there, there's a Nobel Prize waiting for you, not to mention fame and fortune, if you can overturn this, overwhelming scientific consensus. So I call on you to show your work. Show your work in the peer-reviewed international scientific literature and prepare to accept your Nobel Prize. So what are the impacts of climate change? Well, I like to divide them up into 2 categories: impacts on the physical and natural world. I'm just going to hit the highlights here. Increasing frequency and intensity of severe storms, heat waves, and cold snaps. Increasing frequency and intensity of floods in wet regions. Increasing frequency of droughts and wildfires in dry regions like our region. Decreasing mountain snowpacks and earlier snow melt. Rising sea levels, and we learned in Lecture 2 that in the long term, rising sea levels are going to be the big problem. Because even if we stabilize the Earth's temperature at the end of this century, it's say 2 degrees, 2.5 degrees above pre-industrial, the sea level is going to continue to rise for many centuries because there's a many centuries time lag between warming Earth and melting ice sheet. So that's going to be a big problem in the long term. Future generations are going to have to either relocate about half of the world's population inland or cool the Earth back down. Decreasing or increasing mortality of coral reefs, also known as coral bleaching, decreasing productivity of fisheries, increasing species migrations and extinctions with loss of biodiversity. In terms of human consequences of a warming world, again, just going to hit the highlights: increasing economic costs, increasing competition among nations for water and food, increasing displacements of people, leading to unrest, increasing threats to human health, increasing mortality from heat waves, floods, and other severe weather events, lack of food, lack of fresh water, disease, and war. And these risks are generally greater for disadvantaged people living on the edge, particularly but not exclusively in developing countries. Now, I haven't come out and stated this explicitly, but you've probably read between the lines and sort of come to the same conclusion. It's a really important thing, and I want to state it up front explicitly, and that is climate change is a global problem and thus requires global cooperation and global solution. So important, I'm going to say it again. Climate change is a global problem and thus requires global cooperation and a global solution. So that brings us to the topic of international organizations. And I want to begin with the IPCC, the Intergovernmental Panel on Climate Change. I'm sure you've all heard about the IPCC. They're often in the news. The IPCC is the internationally recognized single authoritative voice for advising policymakers on the science of climate change. The IPCC was established by the United Nations World Meteorological Organization, the WMO, in 1988. IPCC is an organization of 195 governments that are members of the United Nations or WMO. Now, the IPCC is divided into 3 working groups and a task force. Working Group 1 focuses on the physical science basis of climate change. Working Group 2, climate change impacts, adaptation, and vulnerability. And finally, Working Group 3, mitigation of climate change. There's also a task force which works on development of national greenhouse gas inventories. Now, the IPCC provides regular assessment reports on the scientific basis of climate change, its impacts and future risk, and options for adaptation and mitigation. These are called AR1 and AR2. AR1, the first one issued was in 1990. AR2 in 1995 was a watershed event. That was the first time when the IPCC came out with wording that said, we're beginning to see the impact of humans on climate change. It's here. We're starting to see it. That caused a huge uproar, and we'll talk about it a little bit later on in the policy part of this. Now, the IPCC does not conduct its own research. Instead, it draws conclusions from the thousands of scientific papers published each year on climate change. Collaborating with the IPCC is a prestigious thing. So there are thousands of scientists all around the world who are chomping at the bit to work with the IPCC, to be invited to be, on their committees, to maybe be the lead author of a report and so forth, is a very prestigious thing. Now, you probably heard in the news that AR6, the latest report from the IPCC, came out last fall. The thing about it is, it's actually 3 different reports, actually 6 different reports. There's the main report where there's one report produced by each of these 3 working groups, comprising so-called AR6. Each report is about 3,000 to 4,000 pages long. It's a lot of material. And then for each report, there is a sort of an executive summary, a summary for policymakers, which is about 40 pages long. So if you go to the IPCC website, it'll be a little confusing how to find all this material. This isn't just one link you click on and there's the report, because it's actually 6 different reports. If you want to dig in there a little bit deeper, I recommend you look at the summary for policymakers. It's 40 pages for each one of these. And there's a lot of great material in there. Pretty much everything you need to know is there, but it can be a little bit awkward finding all that material. I want to give you a heads up on that. So that's the IPCC. I consider the IPCC certainly to be the single authoritative voice. Now, the IPCC has come under some criticism by the scientific community for being overly cautious. I personally think they do a great job of finding the scientific consensus, and that's what I brief in all my presentations, scientific consensus. But scientists tend to be a cautious lot, and therefore it isn't surprising that the scientific consensus is often kind of on the cautious side. When you go back and look at the progression of IPCC reports, you find that they have tended to err on the cautious side. As time has gone by, they've said, well, it's actually happening faster than we thought. They've come under some criticism for that, but I think they're doing the right thing. What you don't want to do is err on the side of being alarmist and having to draw back what you've predicted. I think they do a pretty good job of finding the scientific consensus, and I think that's what we kind of really need to be. The next organization I want to talk about is the World Climate Research Program. WCRP helps to coordinate global climate research, established in 1980 under the WMO again. WCRP aims to foster initiatives in climate research which require or benefit from international coordination and which are unlikely to emerge from national efforts alone. WCRP does not fund climate research directly, but advises research funding agencies on global research priorities. The largest group of contributors to WCRP are several thousand climate scientists from around the world who volunteer to help organize workshops in key areas of research, lay out avenues for future research, and serve on WCRP's science or advisory boards. Again, like the IPCC, it's a prestigious organization, and being associated with is a matter of prestige for climate scientists. And most importantly, and we talked about this actually in Lecture 3, is that WCRP is the sponsor of CMIP. That's the Coupled Model Intercomparison Project, which provides the basis for the climate projections made by the IPCC. It's organized and conducted by WCRP. We talked a lot about, in Lecture 3, we talked a lot about the CMIP ensemble, and indeed, this is where this comes from the World Climate Research Program. Next organization worth noting is the UN Environment Program, UNEP. UN Environment Program is really focused more on ecosystems and biodiversity and things like that. They have some overlap with climate change. Climate change is not really their main focus. However, they do one thing that's extremely important, and that is UNEP produces the annual emissions gap reports that look at the differences between how much greenhouse gas emissions need to be cut to achieve the goals of the Paris Accord and how much these emissions have actually been cut. And we're going to take a look at their latest report. Their report comes out every fall. We're going to take a look at the one that came out this past fall. Spoiler alert, world is not doing very well. We'll get to that in some detail in a minute. So that's a whirlwind tour of the important international organizations. Now I want to move on to international agreements. The granddaddy of them all was the UN Framework Convention on Climate Change, UNFCCC. UNFCCC is an international treaty signed at the Rio Earth Summit in Rio de Janeiro in 1992. The objective is to stabilize greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system, quote unquote. The framework sets non-binding limits on greenhouse gas emissions for individual countries, but contains no enforcement mechanisms. Instead, the framework outlines how specific international treaties may be negotiated to specify further actions towards the objectives of the UNFCCC. UNFCCC includes 197 signatories, enjoys broad legitimacy due to its nearly universal membership, and most importantly, the UNFCCC signatories meet in annual Conference of the Parties meetings. You probably have heard about this, the COP meetings. There was a big COP meeting just this past fall in Glasgow, and I referred to it in earlier lectures. These meetings assess progress in dealing with climate change and consider additional international agreements. And the two big international agreements that have been put in place, the Kyoto Protocol and the Paris Climate Accord, were established under the auspices of the UNFCCC and signed at UNFCCC COP meetings. So let's talk about Kyoto. The Kyoto Protocol was an international treaty adopted in Kyoto, Japan in 1997 at the third UNFCCC COP meeting that committed countries to reducing greenhouse gas emissions. It assigned legally binding targets for reduction of CO2 emissions to each country. The Kyoto Protocol had teeth. It's the only agreement out there that really had teeth. Legally binding agreements. It allowed for trading of emission reduction obligations among countries, so sort of a cap and trade kind of process. It also generally placed more of a burden on developed countries with a history of significant greenhouse gas emissions, for example, the US, than on developing countries. And recall, in lecture 2, we looked at history of greenhouse gas emissions, and we found that in 2 of the 3 categories involving greenhouse gas emissions, the US is number 1. We're number 1 per capita emissions. We're number 2 in existing instantaneous emissions, second only to China. And finally, we are number 1 by a wide margin in terms of what country has put the most greenhouse gases into the atmosphere since the beginning of the Industrial Revolution. We're number 1 by far. And as a result, we were going to be shouldering most of the burden. Now, this fact, plus a heavy lobbying and disinformation campaign by the fossil fuel industry to create doubt about the science, this was taking place in the 90s, led to the Byrd-Hagel resolution just before Kyoto, which passed 95-0 in the Senate and undercut the U.S. commitment to Kyoto, essentially dooming the agreement. Although the Kyoto Protocol was signed by the U.S., the Clinton administration did not even attempt to have it ratified in the Senate. It was made clear by the Byrd-Hagel resolution it would never be ratified in the Senate. When President George W. Bush came in, he opposed the protocol and declined to pursue its ratification, making the U.S. the only signatory not to ratify it. Now, the first commitment period started in 2008 and ended in 2012. Canada withdrew from the protocol in 2011, while Japan and Russia stated that they would not take on further Kyoto emissions reduction targets. A second commitment period was agreed in 2012, known as the Doha Agreement to the Kyoto Protocol, in which 37 countries had binding targets for the period 2013 to 2020. However, the Doha Amendment was never received sufficient ratifications from the members to enter into force. In general, the Kyoto Protocol ended up a disappointing failure, and to a great extent, that was because the United States essentially pulled out initially. And that's a very important concept. The United States needs to lead on these issues, needs to lead on issues in general in the world, and when we fail to lead, things just don't happen. So let's take a look here. We've looked at this before, and this is a brand new chart, by the way. This is updated all the way up to June 3rd. This is CO2 concentrations in the atmosphere, and of course here in the pre-industrial era, for thousands of years, it was about 280, and then in the industrial era, it started skyrocketing. We're now up here over 420, I believe. Highest CO2 levels in 4 million years. You got to go back 4 million years to find CO2 levels this high. So where is the Kyoto Protocol here? Where do you see it? Well, I'll show you where it is. It's right there. And, you know, there might be a little bump here. There might be a little bit of a bump there, but not much. It just keeps on going up. So that's why I think it's fair to say that the Kyoto Protocol had no obvious impact on the rise of CO2 in the atmosphere. Now, the Paris Climate Accord, I'm sure you've all heard about, is the successor to the Kyoto Protocol. It was negotiated by 196 countries and adopted by consensus in 2015 at the 21st UNFCCC COP meeting. Here's President Obama is somewhere in here in the middle, signing the Kyoto Protocol, or the Paris Climate Accord. The aim is to limit the increase in global average temperature to well below 2 degrees centigrade of pre-industrial levels, with a preferred goal of 1.5 degrees C above pre-industrial levels. Pre-industrial levels here are defined as the 1850 to 1900 average. Now, under the agreement, each country must determine, plan, and regularly report on the contribution that it undertakes to mitigate global warming. Unlike the Kyoto Agreement, Paris contains no legally binding emission targets. Kyoto had teeth, Paris does not. No mechanism forces a country to set specific target by a specific date, other than peer pressure from the other countries. Now, in June of 2017, President Trump announced his intention to withdraw from the agreement. With the U.S. again failing to lead or even participate in achieving the goals of Paris, other countries quickly began falling behind their commitments to curb greenhouse gas emissions. Upon taking office, President Biden immediately put the U.S. back into the Paris Accord. At the 26th UNFCCC COP meeting in Glasgow this past fall, countries made various emissions commitments that would hold 2100 global warming to 2.2 to 2.7 degrees above pre-industrial, falling behind the agreement. The initial agreement said we want to hold it well below 2. 1.5 is really the target. Right now, we're at about 1.1. Right now, you know, commitments are there, 2.2 to 2.7, which means my prediction of 2.5 degrees warming by the end of the century, which I made very clearly at the end of lecture 3, is kind of right in the middle of that zone there. So there's where Kyoto was signed. Maybe a little bump there. Here's where Paris was signed. No indication whatsoever. It's going right up. Has no impact so far. You know, not good. So how are we doing? I mentioned the United Nations Environment Program report card. This is basically a report card. It's the emissions gap report. I call it a report card. This one just came out this past fall. And it says, following an unprecedented drop of 5.4% in 2020, global carbon dioxide emissions are bouncing back to pre-COVID levels, and concentrations of greenhouse gases in the atmosphere continue to rise, as we just saw from that previous slide. New mitigation pledges for 2030 show some progress, but their aggregate effect on global emissions is insufficient. Only 10 of the G20 members, and that would be Argentina, China, European Union, India, Japan, Russia, Saudi Arabia, South Africa, Turkey, and the UK, are on track to achieve their previous nationally determined contributions. You'll see this term NDCs. That means nationally determined contributions. That's how much each country is going to contribute to cutting greenhouse gas emissions. Anyway, only 10 of the 20 are on track for cuts, while the remainder, including the United States, are off track. A promising development is the announcement of long-term net zero emissions pledges by 52 parties, covering more than half of global emissions. However, these pledges show large ambiguities, and that's a big problem with a lot of these international agreements. They become rather ambiguous, you know, as to how, you know, are we really going to do this or not? Few of the G20 members' NDC targets put emissions on a clear path towards net zero pledges. And recall in lecture 3, we talked about, you know, to get where we would like to be, to hold it warming to 1.5 by the end of this century, we really need to get to net zero by 2050. Which means we have to make a cut of about 2 in emissions by 2030 and a cut by about a factor of 3 by 2050, and keep on cutting from there to pretty close to 0. Anyway, global warming at the end of the century is estimated at 2.7 degrees centigrade if all unconditional pledges are fully implemented. That means stuff we said, we're definitely going to do this. And 2.6 if all conditional pledges are also implemented. That would be pledges that we say, yeah, we'll do this if such and such happens. And if the net zero emissions pledges are additionally fully implemented, this estimate is lowered to around 2.2 degrees centigrade. So it all is about these pledges. You know, the pledges haven't held so far, so you have to be a bit skeptical on that. So now I'm going to move into talking about U.S. legislation. Now, I generally don't like to talk about politics in these talks. I'd like to keep my climate talks apolitical. But when you're giving a talk on policy and you're talking about legislation, it's pretty almost impossible to not to talk about politics. So if politics makes you queasy, fasten your seatbelts and take a Dramamine, because we're going to be on a wild ride here. All right. So the 2021 infrastructure bill. The $1 trillion bipartisan infrastructure bill was signed into law by President Biden in November of 2021 and included the following climate-related spending: $50 billion for climate resilience and weatherization, $65 billion for clean energy and grid-related investments, $3.5 billion for development and deployment of direct air capture technology. We talked about that briefly last week. I think there was these 4 hubs that are going to be deployed to demonstrate direct air capture. $7.5 billion to build a national network of charging stations for electric vehicles, $21 billion to clean up Superfund and brownfield sites and cap orphaned oil and gas wells, which are a source of lots of leaks of greenhouse gases. Now, the infrastructure bill includes only about 20% of President Biden's climate agenda. The remaining 80% was relegated to the Build Back Better Act. Build Back Better Act. Well, the Build Back Better Act is the largest effort to combat climate change in American history and proposes $555 billion for bolstering resilience and natural solutions to climate change through investment in coastal restoration, forest management, and soil conservation, delivering substantial consumer rebates and tax credits to reduce costs for middle-class families shifting to clean energy and electrification, ensuring clean energy technology from wind turbine blades to solar panels to electric cars will be built in the United States with American-made steel and other materials, and advancing environmental justice. Now, the Build Back Better Act passed the House in 2021, but has not come up for a vote in the Senate because Democrats have been unable to obtain the 60 votes necessary to overcome a Republican filibuster against it, so it hasn't advanced. Instead, the Democrats have adopted a strategy of attempting to pass the bill through the budget reconciliation process, which avoids the filibuster. Budget reconciliation is a process which can be exercised twice a year, can be used to pass bills with only 50 votes, doesn't go through the regular order, which involves the possibility of a filibuster. But it can only involve legislation that has a budgetary impact. For example, you couldn't pass voting rights legislation through budget reconciliation. It doesn't have a budget impact. But Build Back Better Act certainly does. So in principle, it could be passed with 50 Democratic votes. That would be 50-50 in the Senate, and then Vice President Harris would come in and break the tie, and it would pass. The problem is there have been 2 holdouts. One is Joe Manchin, who seems to be the principal holdout, and the other is Kyrsten Sinema. I think Sinema may have come around, but Manchin has been continuing to hold out. And as a result, who knows where this is? I don't think anybody knows where this is and what's going to be in the bill or whether anything's going to happen this summer anyway. We're in the middle of an election year. We're in the middle of election season. It's pretty unlikely anything is going to pass between now and the election. There's the possibility some things could pass in the lame duck session, which comes after the election, before the 117th Congress comes to an end and the 118th Congress gets seated next year. But I would say it's about 50-50 at best, and it really comes down to Joe Manchin to a great extent. Joe Manchin, by the way, is from the coal-producing state of West Virginia. He has close ties to the fossil fuel industry, and you know the story on all of that. Carbon pricing. Now, carbon pricing is an important topic. Carbon pricing is an important policy tool for addressing the climate crisis by providing the public with a pricing incentive to bring fossil fuel use down. Generally places a tax or a fee on fossil fuels at or near the point of production and returns some or all of the revenue to consumers, such that those who are heavy consumers of fossil fuels lose money, while those who are light consumers of fossil fuels make money. The taxes or fees go up over time to increasingly discourage fossil fuel use. It generally includes exemptions for certain sectors, for example, the military, agriculture, et cetera, and a border adjustment, for example, tariffs on imported fossil fuels and other products that have a carbon footprint. Now, some form of carbon pricing is currently implemented in about 60 countries. The US is a glaring exception. There were 10 different carbon pricing bills introduced into the previous Congress, the 116th Congress, including one by our guy, Congressman Jimmy Panetta, the Climate Action Rebate Act, the CAR Act, which I felt was one of the very best ones. It was really excellent. But it didn't pass. But now there are currently 4 carbon pricing bills before the 117th Congress. The Market Choice Act, the Clean Future Act, the Agriculture Resilience Act, and the Energy Innovation and Carbon Dividend Act, EICDA, the one I want to talk about in more detail. That's the one sponsored by the organization I belong to, the Citizens Climate Lobby. But before getting into that, I want to come back to this idea of tax or fee. A tax is not a fee. There's a difference here. A tax, the government would take money in from, say, fossil fuel use, have that money, put it in the general fund. You could use it for anything. You could use it to fund the military. You could use it to build schools. You could use it to build roads. It's a tax that goes in the general fund and can be spent anyway. A fee is money collected by the government for use of something. For example, when you go to a national park, you pay a fee to go in there and use that park. A fee does not go into, the money from the fee does not go into a general fund. It's for a specific particular application. So let's talk about EICDA. EICDA, in my opinion, is the most important one. And by the way, it's the granddaddy of all carbon pricing bills. It was the first one introduced into the Congress, and most of the others have pretty much copied it in many ways. It's sponsored by the organization I belong to, Citizens Climate Lobby. It was introduced into the 117th Congress as H.R. 2307 by Ted Deutsch, Democrat of Florida, with 95 House co-sponsors, including 26 from California. It's currently under consideration by the Energy Subcommittee of House Ways and Means, and the key elements are, number one, a carbon fee, not a carbon tax, a carbon fee. It puts a fee on fossil fuels at the source, which starts low and grows over time, goes up each year, to incentivize consumers to move toward cleaner, cheaper solutions. That money is then given back to the American people in the form of a carbon dividend. Money collected from the carbon fee is allocated in equal shares every month to the American people, minus a 2% administrative cost. About 2/3 of households will break even or receive more than they pay in higher energy prices. A household of 4 initial years would get about $2,000 a year back in terms of this fee, and that would compensate for the amount of additional cost at the gas pump. What would it cost at the gas pump? First year would be about 15 cents a gallon more because of this carbon fee, about 1 cent a kilowatt hour more in your electricity bill. Family of 4 get back about $2,000 to compensate for that. If you're a low user of carbon fuels, you're going to make money. If you're a high user, you're going to lose money. And that fee goes up year after year, such that there is more and more pressure to use less carbon fuels. There's the border adjustment to protect U.S. jobs. So, for example, if you're buying widgets from Australia, let's say, and there's a company here building a widget for $120, and the $20 over $100 is due to the carbon fee. Australia is building that same widget for $100 because they have no carbon fee. Well, when the widget comes into this country imported, there's going to be a $20 top tariff put on it, so it's going to equal. By the same token, if we are exporting a widget to Australia, and it costs $120, whereas they're building widgets down there because they don't have a carbon tax for $100, well, the company will get a $20 rebate to even things out. Exemptions for ag and military, among others, and, well, I mentioned that, and also the rebates for, and finally, rebates for development and application of carbon capture, utilization, and storage technology, which we talked about in the last lecture. Now, this would be fully implemented the year after signed into law, would be phased out when the U.S. carbon emissions fall to 10% of 2010 levels. And this is designed to help the U.S. reduce carbon emissions by 50% by 2030 and achieve net zero carbon emissions by 2050. It will also help improve health and save lives by reducing air pollution because, as you know, there's lots of health impacts associated with, for example, emissions from coal-fired power plants. Now, here's some facts relevant to EICDA. Yale economics professor Dr. William Nordhaus won the 2018 Nobel Prize in Economics for his research related to carbon fee and dividend, which is the basis for EICDA. So there is Nobel Prize winning economics behind this concept. In a 16 January 2019 statement in the Wall Street Journal, 27 former Nobel Prize winners in the economic sciences, 12 former chairpersons of the President's Council of Economic Advisors, 4 former Federal Reserve chairpersons, and 2 former Treasury secretaries endorse carbon fee and dividend. As I mentioned, carbon pricing is employed by 60 countries around the world, with only 2 of the 43 developed nations having no form of carbon pricing in place. That's Australia and the United States. EICDA is by far the most widely supported carbon pricing bill in Congress. It's endorsed by 1,029 prominent individuals, 1,341 businesses, 53 educational institutions, 174 faith groups, 160 local governments, 328 nonprofit organizations, 33 news media organizations, 7 tribal entities, and 127 miscellaneous organizations. Enjoys very wide support. And a couple of things about carbon pricing in general. There's concern, will this spur inflation? Will this cost jobs? Well, there's a lot of experience out there to build on, implemented in 60 countries. And the answer is it doesn't do any of those things. It's very benign towards the economy. So that's the EICDA. The next thing I want to highlight is the Growing Climate Solutions Act. Now, this is really interesting. This bill passed the Senate in 2021 with overwhelming bipartisan support, which is unheard of this day. It passed the Senate 92-8, 92-8, so huge, overwhelming bipartisan support there. It authorizes the Department of Agriculture to help farmers, ranchers, and private forest landowners participate in a voluntary carbon credit market, cap and trade kind of market. Includes the buying and selling of agriculture and forestry carbon credits. It recognizes a wide range of activities as potentially generating carbon credits, including and encouraging land or soil carbon sequestration, emissions reductions resulting from fuel choice or reduced fuel use, livestock emissions reductions, on-farm energy generation, energy feedstock production, fertilizer or nutrient use emissions reductions, reforestation, forest management, preventing the conversion of forest grasslands and wetlands, restoring wetlands or grasslands, grassland management, including prescribed grazing. All things we really want to see happen, the kind of things that we talked about in lectures 4 and 5 with regard to the initiatives from the Project Drawdown. So where is it now? Well, it's currently stalled in the House Agriculture Committee over concerns raised by the committee's ranking member, Representative Glenn Thompson, Republican of Pennsylvania. This is really surprising to me. I mean, normally things pass the House, they get to the Senate and they die there. This is something that passed, not only passed the Senate, but passed overwhelmingly in the Senate, came to the House, and now it's stuck in the House. I think, as far as I can tell, it's this one guy who's the ranking member there. So you wonder why, how can that happen? He's not the chairman. You know, the Democrats hold a majority. They have a 47-44 majority on the Agriculture Committee. Why don't they just call a vote and move the bill along, and it'll pass the House, and President Biden will sign it? Well, all I can think of is that there's some Democrats who are afraid to vote for it because they anticipate that Congressman Thompson will become the chair, you know, almost certainly when Republicans take over Congress in next January. And maybe they're worried about, well, if I vote against him, what's he going to do? How am I going to fare in the next farm bill? Is there going to be retribution there? Right now it's stuck there, which is really surprising. I did actually listen to an interview with Thompson, and I think it was like 6 months ago, and he seemed kind of positive about it. He said, you know, I can see this going across the finish line, but I want to hold some hearings. I just got to hold some hearings. Well, they held some hearings, and he came out and said, you know, I think this is a big government program looking for a problem, and I don't like big government programs. And so that's where it stands right now. It's stuck, which is unfortunate. Is it going to pass? I think unlikely this summer, maybe. But like I said, we're in the middle of election year or middle of election season. The Republicans are loath to give President Biden and the Democrats any kind of victory between now and the election. I think that's for certain. Maybe something could happen in the lame duck session. If not, we're starting over from zero, you know, next time. Now, in addition to the legislation we have talked about, there are over 600 other bills related to climate change currently pending in the 117th Congress. Now, this might make you think that we're on the verge of massive progress in climate change. Well, you would be wrong in that assumption. You would be way wrong. Because given the current dysfunction and gridlock in Washington, none of these bills will ever be signed into law. Most are just intended to make political statements that a member's constituents will like, and some, indeed, are intended to hamper, not help, the government's ability to deal with the climate crisis. For example, H.R. 5372, to prohibit the Department of Health and Human Services from using any federal funds to create or maintain an office to address climate and health equity or any climate change program, project, or activity. H.R. 6692, to prohibit the obligation or expenditure of funds related to the Climate Change Professionals Program and any program, project, or activity relating to climate change or the Department of Homeland Security. H.R. 2798, to provide for the withdrawal of the United States from the United Nations Framework Convention on Climate Change, the UNFCCC that we started out talking about. House Resolution 125, to oppose the use of the National Emergencies Act to declare a national emergency related to climate change. H.R. 7481, to prohibit the obligation or expenditure of funds relating to the Office for Environmental Justice and any other program, project, or activity related to climate change of the Department of Justice. H.R. 420, no taxpayer funding for the Paris Climate Agreement Act. House Resolution 113, expressing the sense of the House of Representatives that the United States should formally withdraw from the Paris Agreement. Concurrent Resolution 34, which means concurrent with the Senate, expressing the sense of Congress that a carbon tax would be detrimental to the United States economy. And finally, my favorite, House Resolution 59, expressing the sense of the House of Representatives that the Paris Agreement shall have no effect in the United States until it is renegotiated to ensure the world's largest emitters of greenhouse gases, which includes the United States, we're number 2, reduce their greenhouse gas emissions and receives the advice and consent to ratification of the United States Senate. So it's kind of a catch-22 here, you know. You know, we have to, we can't exercise the recommendations of Paris unless we bring our greenhouse gas emissions down, but you know, we're one of the 2 largest polluters. So, you know, if it sounds like some of these bills were written by climate change deniers, well, that brings up my next topic, which is climate change denial. But before I get into that, I want to read this statement to you. This is from an article on the effect of CO2 on the climate. Let's read it verbatim. There is evidence that the amount of carbon dioxide in the Earth's atmosphere is increasing rapidly as a result of the combustion of fossil fuels. If the future rate of increase continues as it is at the present, it has been predicted that because the CO2 envelope reduces radiation, the temperature of the Earth's atmosphere will increase, and that vast changes in the climate of the Earth will result. Such changes in temperature will cause melting of the polar ice caps, which in turn would result in the inundation of many coastal cities, including New York and London. Now, this is a remarkable statement, not because what it says, but because of who said it and when it was said. This appeared in Air Pollution in the Coal Industry, article by James Garvey, in August of 1966. Garvey was president of the Bituminous Coal Research Incorporated, and this was in Mining Congress Journal. This is an indicator that the fossil fuel industry knew way back then that there was a big problem here. And this is just one of many examples. And a really good way to learn more about that is to visit the Frontline website. It's pbs.org/frontline, or you can go on the Frontline YouTube channel and find a 3-part series they did called The Power of Big Oil. And here you can go on their website and just click on these and watch these 3 one-hour segments. It's really, really excellent. And it really takes you back to, it tells the story from about the early 80s through the present time. And don't take my word for it. Listen to the people in their own words, the people that work for the ExxonMobils of the world and did the research, and the people who made the decisions on how the fossil fuel industry was going to proceed on this, the PR firms that were engaged by the fossil fuel industries. It's really excellent. I strongly recommend it, and I want now to play the trailer of episode 1 so you'll get a feeling for what it's like. So here we go.
150 years, oil and gas has played a critical role in our society, improving human lives, raising standards of living, and enabling unprecedented economic growth.
What do you do when your industry can no longer exist without creating catastrophes worldwide?
The impacts of climate change are intensifying.
It's important to understand the past. You can't understand where you are if you don't know how you got there.
In a special three-part series, the epic story of our failure to tackle climate change.
The whole world is heating up.
And the role of the fossil fuel industry.
The big oil knowingly spread disinformation.
Now, in part one, what big oil knew about climate change more than 40 years ago.
The fact that Exxon had been doing rigorous peer-reviewed research in the 80s was staggering to me.
There were uncertainties, but the uncertainty was when, how fast.
And what happened as the science became more certain.
Scientific evidence remains inconclusive as to whether human activities affect the global climate. So there's simply no reason to take drastic action now.
They realized that it was going to be an existential threat to their business, but they made a deeply unethical decision to try to obfuscate the reality.
We continue to maintain a position that has evolved with science and is today consistent with the science.
We won't solve the climate crisis unless we solve the misinformation crisis.
So again, I strongly recommend that series. It's really excellent. So let's talk about climate change denial. To avoid taking responsibility for the role it has played in causing climate change and to maintain its core business, the fossil fuel industry and its allies have been conducting a climate change denial campaign since the early 1990s to disseminate disinformation to the public, attempting to create the appearance of scientific controversy where there is none. In addition, the industry has provided substantial funding to politicians who lean toward climate change denial or at least inaction. This strategy is completely analogous to the organized denial of the hazards of smoking by the tobacco industry in the late 50s through the 1990s, and even involves some of the same PR firms and people. And you can see, this is some examples of that. So let's take a look here. Global warming is a huge fraud. Drill now, drill here. Yes, coal, clean, carbon neutral coal. That would be the same coal that's the most dirty, polluting of all the fossil fuels. CO2 is not a pollutant. I love CO2. Total eclipse of the truth. Solar activity, not carbon emissions, controls all weather and climate. Be happy, not conned. Never mind those Nobel Prize winners who say that's ridiculous. There are literally hundreds of websites out there. Globalclimatescam.com, all these things going, global warming hoax. There's literature out there, there's books, there's everything. Here's poor Al Gore here, down here, having a headache with all this going on. And of course, it doesn't help to have a climate denier as your president. Let me just read some of these tweets to you. The concept of global warming was created by and for the Chinese in order to make U.S. manufacturing non-competitive. Snowing in Texas and Louisiana, record-setting freezing temperatures throughout the country and beyond. Global warming is an expensive hoax. Now, of course, in lecture 2, we talked about why global warming actually increases cold snaps because of the way the jet stream reacts. NBC News just calls it the Great Freeze, coldest weather in years. Is our country still spending money on the global warming hoax? Give me clean, beautiful, and healthy air, not that same old climate change, global warming bullshit. I'm tired of hearing this nonsense. So the campaign to undermine public trust in climate science has been described as a denial machine and is largely carried out by about 90 think tanks, advocacy groups, trade associations, and lobbyists that are funded right now at about $1 billion per year. About $1 billion a year is coming from the fossil fuel industry and going out to these groups. The Global Climate Coalition is actually no longer in existence, but it was the first of these, and it was a major player, and you'll hear a lot about what they did, and you'll hear a lot directly from some of the people that work there in that Frontline series. But they're the ones who really turned things around in the 90s. And basically, on the Frontline series, a quick summary, in the 80s, it was becoming apparent to all the ExxonMobils of the world that it was a big problem. Their own scientists were at the table. Their own scientists were doing peer-reviewed leading research. Their research was consistent with the research coming out of academia and coming out of the government. By the end of the 80s, the leaders of the fossil fuel industry said, hey, wait a minute, we got a problem. We got to turn this around, kill the science. They fired all the scientists, shut down the research programs, and they launched into this climate denial effort. And to a great extent, the GCC, the Global Climate Coalition, really kind of led the effort. They were funded by it was a consortium of all the oil companies funding them. And they kind of lay down the playbook and establish the fact they're the ones who killed the Kyoto Protocol, for example. Now, much of this funding comes from the fossil fuel industry, for example, ExxonMobil, Chevron, Shell, American Petroleum Institute, et cetera, as well as from conservative billionaires and foundations with large holdings in the industry. For example, Koch Foundation, Templeton Foundation, DeVos Foundation, et cetera, often working through secretive funding networks in an attempt to hide conflicts of interest. This climate change denial effort, in conjunction with campaign funding for politicians who lean toward climate change denial, has had a significant political impact by creating doubt among the public and inaction in government. However, as shown by recent national polling, climate change denial is failing. And you can see that here. This is a recent poll done in 2021 of adults asking, is global warming happening? The national average is overwhelmingly yes, 72%. Here's how it varies by state. Here's the scale over here. So 72% say yes, global warming is happening. Only 14% say no, and the middle area here is gray area. They don't really quite know. Very strong in California. There are some areas where it's not as strong, but there's no place where there's no state in the country where less than 50% of the people think that global warming is not happening. This is the percent of adults who think global warming will harm future generations. Again, it's overwhelming. 71% say yes, only 19% say no. There are no states where it's less than 50%. And finally, on the question of is global warming caused mostly by humans? And the national average is still high. It's 57%. It's almost 2 to 1. 57% say yes, only 30% say no, gray area here. There's a handful of states that are less than 50%. North Dakota, Wyoming, Oklahoma, Louisiana, Alabama, Kentucky, West Virginia, Indiana. But the national average is quite high. Now, if you went back 20 years and took the same poll, the numbers would be about 20% lower. Just lower them all by 20%. That's about where we would be. So despite all the efforts of the fossil fuel industry and the climate change denial community, the trend is going in the right direction. So the future of climate change denial. These polling results are very encouraging and reflect significant progress in the public's understanding of climate change, despite the efforts of the fossil fuel industry and the climate change denial community to cloud this understanding. It will take time for political leaders to catch up to the public on this issue, but eventually they will. Ultimately, the efforts of the fossil fuel industry and the climate change denial community will fail completely, just as the efforts of the tobacco industry to deny the health hazards of their product ultimately failed, and government will be able to act more decisively in dealing with climate change. And someday, the arguments that have been put forward by the fossil fuel industry and the climate change deniers will seem as wrong and as out of place as a 1950s vintage cigarette ad. So ask your doctor, are camels right for you? So, talking now about public policy challenges. What are going to be the big issues going forward? Well, I kind of list here. Certainly, the political polarization and paralysis in Washington is a big issue. We need to have things done. We need to make progress. Nothing is hardly getting done. Certainly, the red-blue political divide between the states and its reflection in regional views on climate change among both the general public and elected officials is an issue. The need to invest significant amounts of taxpayer dollars to deal with climate change. The need to enact carbon pricing legislation. Land use and environmental concerns related to the deployment of clean energy power plants. Wind farms, particularly offshore wind farms. Solar farms, particularly in environmentally sensitive desert areas. Dealing with the National Environmental Policy Act, NEPA, the Endangered Species Act, ESA. The geoengineering proposals we talked about last week and the concerns about unintended consequences. Ending the tax incentives and subsidies for the fossil fuel industry that we talked about in the last two lectures. And finally, nuclear power. Now, I did talk a bit about nuclear power last week in the Q&A session, but I want to go back and revisit that, partly for completeness and partly because we have new people here today. The four big problems with nuclear power: the existing second and third generation nuclear power plants, possibility of catastrophic failure. This is the MIAC site in Russia, which had undisclosed accidents in 57 and 2017. You know about Chernobyl. This is the Fukushima Daiichi plant on fire after the tsunami 15 years ago or so. Storage of nuclear waste is the second problem. Yucca Mountain was going to be the solution for the storage of nuclear waste, and I personally think it would have been a really good solution. But in the mid-2000s, the good people of Nevada rose up and said, not in my backyard. And so since then, Yucca Mountain has been basically lying fallow. It's in a caretaker status. No work is being done there. No fuel is being stored there. So in that situation, what's happening is nuclear fuel is being stored at each plant in these steel and concrete canisters. That's dangerous. It's not sustainable. All kinds of problems with that. I don't see Yucca Mountain going forward. People of Nevada don't want it in their backyard. Nevada is a purple state. No president's going to campaign on bring back, or no presidential candidate's going to come out there and say, I want to bring back Yucca Mountain. They'll lose the state of Nevada. Third problem is nuclear weapons proliferation. As I mentioned last week, if you own a nuclear power plant, you have a path to nuclear weapons. You have the plutonium path to nuclear weapons. And indeed, that is the path that North Korea has taken. By most accounts, North Korea has about 24 Hiroshima-class nuclear weapons, all made from plutonium obtained by reprocessing spent fuel rods in their reactors. And as a result, Israel, for example, launched a 1981 attack on a nuclear power plant in Iraq. This is an artist's rendition of that. And again, in 2007, Israel attacked a Syrian nuclear power plant. In both cases, Israel was concerned that those countries were going to use those plants to develop fissile material and nuclear weapons to be used against Israel. So that's a big concern. And then the final concern is nuclear power from the existing generation 2 and 3 nuclear power plants is by far the most expensive on the grid. This is the levelized cost of energy we talked about briefly last week. This is sort of the cradle-to-grave cost of power. You take the total cost of a power plant from design phase to implementation, operations and maintenance, even all the way to decommissioning. Divide that by the total amount of power produced by it, and you come up with levelized cost of energy. Offshore wind or onshore wind is by far the cheapest, about 4.6 cents per kilowatt hour. And nuclear power is about four times as expensive, by far the most expensive power on the grid. Why is that? Well, you have to engineer a huge amount of safety into nuclear power plants. They're kind of one-off kind of designs, and they're huge, and they're very expensive. It's very expensive to fuel them. It's very expensive to decommission them. So nuclear power is by far the most expensive power on the grid. So a lot of problems there, 4 big problems. But the story doesn't end there, because there are Gen 4 nuclear power plants now on the drawing board, and Bill Gates talks about that in his book. We talked about that briefly last week. Generation 4 reactors are a set of nuclear reactor designs currently being researched for commercial applications by the Gen 4 International Forum. They're motivated by a variety of goals, including improved safety, sustainability, efficiency, and cost. In my personal judgment, Gen 4 nuclear power plants significantly mitigate but do not completely eliminate the problems of Gen 2 and 3 plants. So it's not a get-out-of-free-jail card here, but they do significantly mitigate the threats from existing plants, and maybe it's a risk we're going to have to take. There are about half a dozen proposed Gen 4 plants on the drawing board. China has announced plans to deploy 2 Gen 4 operational plants by the end of this decade, actually on the grid, using those plants. They're generally safer. Most of them operate at atmospheric pressure because they're able to use, for example, lead or liquid sodium or molten salt as the cooling, as opposed to high pressure water. And as a result, they're not under such high pressure, so there's less chance of them exploding. They also use basic laws of physics to automatically shut down if there's overheating, that kind of thing. Many of them use thorium rather than uranium as the fissile material. that produces less in radioactive material, and radioactive material that doesn't stay radioactive as long, and therefore the radioactive waste problem is not as significant. Some of the designs do not produce any weapons-grade material. However, they can be modified to do so, and they can even be modified covertly to do so. So they don't completely eliminate the nuclear weapons proliferation risk, but they do mitigate it. Now, the one thing you might wonder about is, what about cost? Well, that's a concern. For example, when the nuclear power industry first set out to design their Gen 1 plants back in the 50s and 60s, they looked at thorium and they decided, no, we're going the uranium route, because uranium will be cheaper and it has more efficient breeding cycle. It'd be too expensive to do thorium. So that's a concern. It'd be more expensive using thorium. But there is a new technology around, and it's called small modular reactors, SMRs. Now, small modular reactors are a class of nuclear fission reactors that are smaller than conventional nuclear reactors and typically have an electrical power output of less than 300 megawatts. So to replace a typical existing nuclear power plant, you need about 5 of these. You need to put about 5 of these down side by side. They're designed to be manufactured at a plant and transported to a site for installation. You can actually transport them on the highway, as shown here. As a result, SMRs will reduce on-site construction costs and require fewer personnel for operations than a traditional nuclear power plant. They achieve enhanced safety through use of passive safety features that operate without human intervention. The term small modular reactor refers to the size, capacity, and modular construction only. This is like, it's like assembly line production. They're all going to be the same, as opposed to each plant being a one-off design. And designs range from scaled-down versions of existing Gen 2 and 3 plants to Gen 4 designs. So you can imagine that we'd be deploying small modular reactors in the Gen 4 design. Now, a handful of SMRs are currently nearing deployment. Some are being built in the U.S. I'm not sure any are being built to be deployed in the U.S., but there are some being manufactured in the U.S., and that has potential to be a game changer, I think. So I want to now move to closing comments. My good friend Linda Charles ran to me one day and she said, I love your climate change series, it's fantastic. Can you boil it down to 5 key takeaways? It wouldn't be cool if you could make 5 key takeaways. So I took that to heart, and here's my 5 key takeaways about climate change. Number 1, it's happening and it's accelerating. Number 2, humans are causing it, mainly, but not exclusively, through the burning of fossil fuels. Number 3, if left unchecked, it will have a devastating impact on future generations. Based on the science, number 4, based on the science, we have the time and the technology to halt it by the end of this century. But number 5, unfortunately, at this juncture, we lack the political power and the political will to do so. So what can you do as an individual? Well, you can learn as much as you can about the science, technology, and policy pertaining to climate change. And participating in this series is a great way to do that. You can do what you can to reduce your carbon footprint while still living the life you want to live. You can use your position of leadership in the community to advocate for climate action. Whenever you have an opportunity to interact with other leaders in our community, be they political or otherwise, let them know that you want to see action taken on this issue. You can vote for candidates who will address your concerns about climate change. And by the way, Jimmy Panetta, our guy, has been fantastic on this issue. I've been pretty negative about Congress in general here, but I got to tell you, Congressman Panetta has been a real leader. He's a member of the Climate Solutions Caucus. He authored the CAR Act, which was excellent. He has a 100% perfect rating by the environmental, get it wrong, environmental, I can't quite remember the group, but it's an environmental advocacy group. You can join an advocacy group, such as Citizens Climate Lobby, and participate actively. So let me talk a little bit about CCL, which I belong to. Citizens Climate Lobby is a nonprofit, nonpartisan, grassroots advocacy climate change organization focused on national policies. CCL was founded in 2007 by the late Marshall Saunders and is comprised of over 400 chapters and over 208,000 members in the United States, as well as more than 150 chapters and over 19,000 members internationally. CCL's consistently respectful, nonpartisan approach to climate education is designed to create a broad, sustainable foundation for climate action across all geographic regions and political inclinations. CCL's top priority is achieving the political will necessary for passage of the Energy Innovation and Carbon Dividend Act, EICDA. Now, it's easy and free to join CCL. There's no dues. Just Google Citizens Climate Lobby, and you'll come to their homepage here, and just click Join CCL. With a Monterey County address, you will automatically become a member of the Monterey County chapter, and I will be in touch with you. I'm chair of the Monterey County chapter. We have monthly meetings via Zoom, and we're planning some future activities maybe you can be part of. Well, coming now to my final comments. You know, this has been a lot of fun. You know, I've actually been up here about 7 hours, speaking about 7 hours. And great you guys have hung in there with me on that. I've showed you over 300 slides, spoken for 7 hours. So I thought it would be appropriate to end on sort of a light, whimsical note. And for that reason, that brings me to the next topic, which is threats to the future of civilization. Well, I think the top threat is indeed the possibility of global war, World War III, in conjunction with weapons of mass destruction, nuclear, biological, chemical, and cyber. I note I include cyber here because, you know, the electric grid, our water system all around the world, this infrastructure that's so critical for human civilization is vulnerable to cyber attack. There's no doubt about that. And so I have to put that on there as a weapon of mass destruction. So this is the big problem, the possibility of global war with now about a dozen countries possessing nuclear weapons. At the end of World War II, only one country had nuclear weapons. World War III, you're going to start with at least a dozen countries having nuclear weapons. Oh, by the way, you know, when Putin invaded Ukraine, he immediately put his nuclear forces on high alert. He has been pretty clear saying, you know, if this escalates, it could turn into nuclear war. He's been very upfront about that. President Zelensky of Ukraine said World War III has already started. So this is not a stretch here. And there are a number of issues that make this more likely. And I've tried to prioritize these. This is my priority here, and I probably have missed some things. I put number one, the rise of autocracy and nationalism, and the decline of democracy and internationalism around the world. Number two, growing competition among nations for economic advantage and even for the very basics of life, food, water, and living space, as a result of overpopulation and depletion of natural resources. Number three, the possibility of global pandemics, even more contagious and deadly than COVID-19. Number four, the effect of massive displacements of the workforce, driven by automation and artificial intelligence, with growing income inequality both within and among nations. Number five, the rise of religious fundamentalism around the world and its role in both international and national conflict. Number six, the weaponization of information and the use of information warfare, both between and within nations. Flood the zone with lies, make the truth unknowable. Flood the zone with lies, make the truth unknowable. That's information warfare, and it's being conducted all around the world, particularly in Ukraine and Russia, and even in our country. And finally, the sometimes fragile nature of national economies, currencies, and financial systems. Imagine cryptocurrency becomes the currency of the world. Imagine that becomes the currency of the world, and financial systems are based on cryptocurrency. Then imagine someone figures out how to hack the blockchain globally all at once. You could have an instantaneous collapse of the global financial system and global currencies. Wouldn't be good. So here's the thing. Climate change cuts across all of these risk factors. It cuts across and exacerbates some of them in ways you might not have thought about. For example, the rise of autocracy and nationalism. What's one of the big issues that autocratic leaders run on and seize power with? Well, it's immigration. You see it in Europe, you've seen it in our country. Where are all those immigrants coming from that are inundating Europe and are giving rise to people like Marine Le Pen and Viktor Orban? Well, they're coming from North Africa, they're coming from the Middle East, and they're coming to a great extent because those areas of the world are gripped by drought. And these people who are subsistence farmers, they can't make a living in the countryside. They go to the cities. They can't make them in the cities. They're heading to Europe. People in Central America and Mexico, gripped by drought, gets worse and worse. Can't make a living farming. Can't make a living in the cities. Drug gangs are rising up. Where are they headed? They're headed to the United States. That becomes fodder for the rise of autocracy. Growing competition among nations for economic advantage including food, water, living space, well, that's absolutely climate change. Food, water, and living space. Living space is the sea level rise. We talked about that. You know, the projections now are 1 meter rise in sea level by the end of this century. That will displace about 100 million people globally, 30 million in Bangladesh alone. Where are those people going to go? Are there going to be people out there welcoming with open arms? I don't think so. And that gives rise to instability. Drought, changing weather patterns makes it hard to feed the world. Increasing population we talked about in earlier talks. Collapsing fisheries makes it hard to provide enough food, fresh water for people in the world. So climate change is a threat and will become a worse threat because it will exacerbate these issues that feed into the ultimate threat, which is global world war. So with that light thought out of the way, I want to leave you finally, and I promise this is indeed the final slide, with three key questions to contemplate. Number one, do we care about the fate of people in our country and around the world who are suffering the consequences of climate change right now? And there are such people, even in our country. Number two, do we care about the fate of future generations in our country and around the world who will suffer much more dire consequences of climate change? And finally, number three, do we care what those future generations are going to think about us when they come to realize that our generation has failed to act decisively to solve this problem? Thanks so much for coming and participating in this series. I really appreciate it. Thank you.